We're going to be discussing number systems today, which is one of the elementary topics you are required to know. So, what is number system? They are just all the set of numbers that you have. We're going to be using this short textbook to explain that. First of all, we have the natural numbers. So, we have the natural numbers. So, these natural numbers, as you can see, they are just the counting numbers, right? They are just counting numbers 1, 2, 3. Now, if you try to add them, you can add natural numbers, you can subtract a bigger natural number minus a smaller one. But the issue arises when you want to subtract. For instance, let's say 2 minus 1. When you want to subtract 2 minus 6, it is now undefined in the set of natural numbers. So there are other numbers that can cover this. Now, set of natural numbers, sometimes the symbol in math is n, right? Set of natural numbers is just n. Now, the other set of numbers that we have set of whole numbers. So whole numbers are just natural numbers with zero inclusive. Natural numbers with zero inclusive. Your natural numbers is just your counting number 1, 2, 3, 4, 5, 6. As you can see here, these are the set of natural numbers, but whole numbers with zero inclusive, that set of natural numbers. It took some years for some people to include the zero into their working mathematical set of numbers. Then we have the set of integers. Set of integers are the whole numbers, the natural numbers, and their negative. For instance, we have this. Can you see this is -7 up to -1, 0, 1, 2, 3. They are all set of integers. We say integers. Now, mathematically, the symbol for integers is z, 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 z. That is set of integers. So we continue. We also have set of rational numbers. Now, set of integers, you can use them to play around with them. You can have like this, -9 plus -5. You can evaluate it under the set of integers. You can have so many other things under the set of integers. You can say -6 plus -7. You can say -3 minus plus -7. All these are under the set of integers, right? Then we have set of rational numbers. Now, set of natural numbers are any number that you can represent as a ratio. In this case, we have A and B. It is not a set of integer. Why? Because if, for example, if you have 2 over 3, then this will give you decimals, right? So for that reason, it is no more in the set of integers. We are talking about the set of rational numbers. Thus, a number which can be put in the form P over Q, where P and Q are integers, right? If they are integers, then this set of numbers, they are called rational numbers. For example, you see -2 upon 3, 5 all over -8. We see that 5 is an integer, -8 is an integer, but when you put them in a form where one is in the numerator and the other in the denominator, then it becomes a set of rational numbers presented as Q, set of rational numbers. Good. So we go further to the set of irrational numbers. So These irrational numbers are numbers that cannot be in the form of P all over Q. Those are the set of irrational numbers. Irrational numbers, you can have them in a form whereby the decimals are not properly arranged, or you have the decimals, they are not repeating, then you can say that those numbers are irrational. So we are going to be talking about irrational numbers. Can you see them? So irrational numbers that are not repeating, or numbers that they do not terminate. Now read, we have seen that the decimal expression of rational numbers is either terminating or is non-repeating. So for instance, you have root 2. When you punch root 2 on your calculator, you can see that those numbers are irrational. They are not, the decimals are not terminating, or they are not repeating. Those sets are sets of irrational numbers. You understand? Because now if you consider the set of numbers that are in between square root of 3 plus 2 over 2, those sets are sets of irrational numbers. But any decimals that are terminating or repeating, they are rational numbers. Now, in this note, that is where the set of number, that is where they stop in the set of numbers. But we have some other. So the set of irrational numbers, you can see them written as I. Set of rational numbers written as I, 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 right? These are sets of irrational numbers. We also have the set of real numbers written as set of real numbers. Now, real numbers properly contain rational numbers, irrational numbers, integers, whole numbers, and then natural numbers. In the set of real numbers, you can have any number whatsoever. You can have minus 3.2, it is also in the set of real numbers. You can have 1, you can have 0, you can have your pi, which is approximately 30, 20, 27 upon whatsoever you have. You can have epsilon, you can have any number you can think of, 2.001. Real numbers contain all the number from negative infinity all the way to positive infinity. Real number, the set of real numbers, right? So you can use the set of real numbers for anything. So properly, where do we start from? We start from the set of natural numbers, right? We started from the set of natural numbers. We started from the set of natural numbers, right? When we went to whole numbers, then we went to integers, z, then we have rational numbers, some that represented as q. We have irrational numbers represented as I. So we have set of real numbers represented as R, and we have the last set. For example, this is just 1, 2, 3, all the way to infinity. When you talk about infinity, infinity can be either negative or infinity can be positive, right? Whole numbers include 0, 1, 2, all the way to positive infinity. Set of integers contain both whole number and real numbers, including their negative, right? So you can start from anywhere in the infinity space, negative, all the way you come to 1, 0, 1, 2, all the way to positive infinity, right? Now, we say that for rational numbers, if you can represent any of these integer, q all over p or r, where q is an integer, r is an integer. For example, 2/10, right? Provided that the decimal terminates, for instance 0.2, this is a rational number. Provided it terminates or repeat, is rational. But if it does not terminate, example √3/2, then is under the set of irrational number. The decimal does not terminate. You can use your calculator to verify this. Now the set of real numbers, we have all the irrational, the rational, the integers, the whole numbers, the natural numbers, right? These natural numbers. Now all of them are considered under the set of real numbers, from negative infinity all the way to positive infinity. So your 2.2 all over 3 is a set of real number, is in the set of real numbers. Your pi, I think is 22/7, is also a set of real numbers. Then lastly, we have the set of complex numbers, which has to do with having a number which is real and then you add it with another number which has the imaginary part. We call it IY. So this must be real number, then this part is what we call the imaginary part. Imaginary. Are we together? Good. So for this imaginary part, you want to use it for solving equation. For example, when you have x squared plus 1 is equal to 0, you can't solve this in the real plane because you can have x squared is equal to -1. So when you take the square root of both sides, you now have -1 under the square root sign, which is insolvable on the real number. So we use the complex number. So stay tuned. We'll be dealing with all foundation courses, all foundation topics. We'll demystify everything that has to do with numbers, and we have plenty of examples in the next video. Stay tuned, subscribe, share. So let's work together. Before this week runs out, we will have plenty of foundation video. If you want to take this document that I have used, you are going to comment down in the comment section. You share the video and then I will send it to you via email. Thanks.